Well, hello, guys. Welcome to another day of science. I'm excited to learn more about some light today. How about you? Well, we looked at our lesson yesterday and we got into some really interesting things about light. We talked about a big word, the electromagnetic spectrum, how light is arranged in different wavelengths and frequencies. We looked at visible light that you and I can see, made up of the colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. We talked about radio waves and how some of their wavelengths can be as long as football fields. So really interesting stuff about light. Today I want us to look at this digital lesson. And so I want you to be a good listener as we go through here. These are really fun. I like the digital lessons because it lets us look at our last lesson in a little different way. So pay close attention today and let's learn some more about light. I'm going to shrink myself a little bit and we'll get into the lesson here.
Are you creative? Do you like rearranging your room? Then you might like my job. I'm an interior designer. I design rooms for people. Here's a bathroom I designed. The people who live here wanted something bright. Click the hot spots to see what I did. Then click next when you're ready to learn more about light and how it travels. I made the windows larger so they would let in more sunlight. It's hard to believe waves of sunlight can be so bright when they travel so many miles through space. I also added very thin curtains, so only a little bit of sunlight would be blocked. I also put in light fixtures so there would be light at night. Light travels out from all directions from the light bulbs, but the frosted glass keeps light bulbs from shining in people's eyes. They also direct light down by the mirror. It's important for me to know how to use light to brighten a space. There are lots of uses for focusing light rays besides just making a room look nice. For example, this lighthouse uses a focused beam of light to help guide ships. Light travels in a straight line until something stops it. The mirror in this room reflects the light or makes it bounce off. A large mirror like this reflects the light and makes the room brighter. Disco balls are covered with many tiny mirrors that reflect light, but I don't think my clients would like one in their bathroom. What do you think?
I don't know about a disco ball in the bathroom either.
Welcome to the lesson, What is Light?, where you'll learn about what light is and how it travels. You'll also find out about how light is used in technology. The vocabulary words for this lesson are light and electromagnetic spectrum. Click each word to find out more about it. Light is very interesting, especially when it forms optical illusions. Have you ever seen a mirage like the one in the video? A mirage forms when light waves bend as they enter warmer air. A mirage can make it look like objects are moved or there is water on the ground. Light is a wave that carries energy. It has many properties. Let's look at some properties of light and how they behave. Click the first image to get started. Light can travel through some objects, but not through others. Light from the sun and stars travels through space and the atmosphere until it hits an object that it can't pass through. A shadow forms when light cannot travel through an object. Light is unique. Many waves, such as sound waves and water waves, require a medium, such as a solid, liquid, or gas, to travel through. Light, on the other hand, does not require a medium in order to travel. Light is able to move through empty space where there is no air. This is how light from the sun and from other stars reaches Earth. As the energy from an earthquake moves outward, the land shakes and can damage anything on the surrounding surface area. There is more energy closer to where the pieces move and less energy farther away from that spot. Once light hits an object, the light can be absorbed, bent, or reflected. Unless a light source is aimed in one direction, such as the light from a flashlight, light will travel outward in all directions from the light source. This is why turning on a light travels outward in all directions. Unless a light source is aimed in one direction, such as the light from a flashlight, light will travel outward in all directions from the light source. This is why turning on a single light can brighten an entire room. Light is a source of energy that travels in waves. Light waves are different than sound waves. Light moves in a transverse wave. Sound waves move in a longitudinal or compression wave. Click play to learn more about light waves. Sound waves and light waves are very different from each other. Sound waves are compression waves, meaning that the medium moves back and forth as the wave travels through the medium. Another type of wave is a transverse wave. In transverse waves, the medium moves up and down as the wave travels through the medium. Waves on the ocean are a type of transverse wave. Light is also a transverse wave, but unlike ocean waves, light waves do not need to travel through a medium in order to transmit energy. Did you know that waves can be measured? A wavelength is the measure of the distance from one crest to the next crest. There is a wide range of wavelengths of light, from meters to nanometers. Light wave properties change when the wavelength changes. You will learn more about these properties later in the lesson.
Do you remember what it's called? That arrangement of light from wavelengths and frequency? That's the electromagnetic spectrum, right? But we're going to learn about it today too.
How do we use lampshades to help direct light? Type your response in the box. When you are happy with your answers, click OK.
All right, so how do we use lampshades to help direct light? Well, these little petals on this lamp, that's a pretty lamp, isn't it? Kind of blocks some of it. If you're sitting here in the chair, you don't want the light shining right in your eye. So it still lets some light through, but it kind of directs it down. So if I'm sitting in this chair reading a book, this lampshade directs the light down towards my book so I can see what I'm reading. So lampshades direct light from hitting us straight in the eyes and to a more useful place, I guess we could say.
Light spreads out in all directions from the source of light. We use lampshades when we want to direct the light where it can be most useful, such as on a desk or a work surface, or to make it easier to read a book. Did you know that we can't see all forms of light? It's true. Our eyes are only able to detect a small range of wavelengths of light. Different wavelengths of light have different properties. We use these types of light in various ways. We can organize light according to wavelength into the electromagnetic spectrum. Click these spots on the bar to learn more about the electromagnetic spectrum.
All right, so here's what we were talking about earlier, the electromagnetic spectrum, all the way from radio waves, long wavelengths, less frequency, all the way up here to gamma rays, which is shorter wavelengths and higher frequency. And you can see all along all the various places. Visible light, excuse me, visible light, making me sneeze. Visible light is here towards the middle. This is the light that we can actually see. Can't see any of the other wavelengths here on the spectrum. So let's learn more about it.
The electromagnetic spectrum separates light by wavelength and properties. The types of light on the electromagnetic spectrum are radio waves, TV, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Looking at the spectrum from left to right, the wavelength gets shorter. The shorter the wavelength, the more energy the light wave has. Radio waves are a form of light. Light waves carry radio transmissions from the radio station to your radio. Radio waves have a very long wavelength and low energy level. In fact, radio waves can be longer than a soccer field. Microwaves have a shorter wavelength, higher frequency, and higher energy than radio waves. People can use microwaves to cook. Cell phone towers also use microwaves to send signals. The wavelength of infrared radiation is shorter than microwaves. It also has more energy than microwaves. Infrared radiation can't be seen by humans, but it can be sensed as heat. Anything that gives off heat releases infrared radiation. This photo was taken by a special digital camera that detects infrared light. There are 4 more types of light that occur on the electromagnetic spectrum. Click the nodes above to learn more about these 4 types of light. Visible light is made of the wavelengths of light that we are able to see. The colors red, orange, yellow, green, blue, indigo, and violet are part of millions of colors that make up the visible light spectrum. Ultraviolet light has a shorter wavelength and higher energy level than visible light. Ultraviolet light can be used to disinfect surgical and dental instruments. Too much ultraviolet light can be dangerous, however. It can cause sunburn, skin cancer, and eye damage. Sunscreen and sunglasses can help protect you from damage caused by ultraviolet rays. X-rays are very energetic waves with a short wavelength. We use X-rays in medicine to view bones and other organs. Gamma radiation is the most powerful form of light. Its wavelength is extremely small, and gamma rays carry a lot of energy. Gamma radiation is used in the treatment of tumors. Different wavelengths of light have different properties and uses. Can you match the type of light to the picture it goes with? Drag the word to the correct image.
All right. Well, this looks like an X-ray to me, doesn't it? I think that goes there. Here's a radio, so that would be radio waves. We just saw that ultraviolet rays can cause a sunburn. That's why your sunscreen says UV protection. UV stands for ultraviolet. I remember that was just the picture they just showed for gamma radiation. And it treats tumors, he said. That's a rainbow. That's the colors of visible light. And infrared goes on this last picture here.
Great work. You've matched them all. The electromagnetic spectrum is organized by wavelength, from longest wavelength to shortest wavelength. As the wavelength of the light gets shorter, the energy in the light becomes greater. Visible light is only a small part of the electromagnetic spectrum. Most light is actually invisible to humans.
So it's interesting to me to think about the shorter wavelength and more frequency makes that light more powerful. So you think about the light from the sun, it can be strong enough, powerful enough to burn us. But think about your microwave. You can cook food. It's powerful enough. Microwaves are powerful enough to cook food. So that's pretty amazing. Light is powerful.
What do you think a laser is? How is it different from other types of light? The word laser stands for light amplification by stimulated emission of radiation. The light from a laser comes from a group of atoms that simultaneously release a burst of a single frequency of light. Click the highlighted areas in the picture to learn more. Lasers are very different from light bulbs. Light bulbs give off many different wavelengths of light, and the light spreads out in all directions. Lasers, however, produce a focused beam of light that is all the same wavelength. A laser beam is a very highly concentrated beam of light that has one specific wavelength. The light waves in a laser are focused in one direction. Laser light makes a bright dot where it hits a surface. The beam is almost invisible unless there are tiny bits of dust or water droplets in the air. A laser pointer's beam cannot pass through an opaque object. However, more powerful lasers can cut or drill. Lasers are used for some surgeries. Lasers are a very useful form of light. They are used in a variety of technologies and help make many jobs easier. Click the images to learn more about the uses of lasers. You've probably used a CD player, a DVD player, or a CD-ROM. Did you know that these machines have tiny lasers in them? The laser is used to read the video or music data on the disc. Lasers are also used to burn or make CDs or DVDs. Lasers are also used in carpentry. Many saws have lasers that can be used as a guide when cutting wood. Carpenters or contractors may use laser levels to make sure that floors, decks, and walls are level. Lasers can also be used in surgery. A person may undergo laser eye surgery to correct their vision. Doctors might use lasers to remove moles or to take samples of tissues. When doctors use lasers to perform procedures, healing time is reduced and there is less scarring. Certain wavelengths of lasers can be very powerful. So powerful, in fact, that lasers can be used to cut steel or other metals. Cutting metal with lasers is much easier, more accurate, and less dangerous than using saws. Barcode scanners use lasers. Before barcode scanners were in use, cashiers had to enter each item's price by hand. Today, laser barcode scanners make checkouts faster and also send inventory data to a central computer. There are many practical uses for lasers. Choose all the images that demonstrate how we use lasers.
Did it say something we use them in carpentry? Yes, they could use it to guide where they're going to cut with a saw, it said.
That's right. Lasers can help carpenters keep their work straight and level.
Reading? Not unless you have laser vision like the X-Men. I don't think you're going to need lasers for reading. Cutting steel? Yeah, we heard that.
That's right. Lasers can be used to cut steel. That's correct. Lasers read information on DVDs and CDs. Great work. You picked them all. Lasers have many practical uses, such as for cutting, measuring, and sharing data. Lasers have made many jobs easier. Light has many characteristics. Which of these describes how light travels in waves? Choose all the correct answers.
All right, the first one says light is a compression wave. That's not right. Compression is like, remember that slinky we talked about? That's sound. It poof, 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 like that. It presses together and then expands, presses, expands. It didn't say light's not a compression wave. It's a transverse wave, it said. Light makes up the electromagnetic spectrum? Yes.
Great work. That's correct. We learn about light with different wavelengths and properties when studying the electromagnetic spectrum.
Light can travel in space. Yes, we learned that. Sound can't because it needs a medium like air, like an atmosphere to pass through, but light does not, so it can travel in space.
That's correct. Light does not require a medium to transmit energy.
Light is a transverse wave. Yeah, that's right. It's not a compression wave. It's a transverse wave like a wave in the ocean, up and down and up and down.
That's right. Light can travel as a transverse wave. Good job. Light is a transverse wave that does not require a medium to transmit energy. Light at different wavelengths exhibits different properties. These different properties are seen when studying the electromagnetic spectrum. Light is divided into categories on the electromagnetic spectrum. Drag the labels to their proper places on the electromagnetic spectrum.
All right. Well, I'm going to start with the one I know for sure. Visible light. We can see it with our eye. There's the colors of the rainbow. So that one goes there. And I'm thinking the longest wavelength down here was radio waves. And that looks like a radio to me. Said they were as long as a football field or a soccer field. Maybe I'm not right. Yeah, I was. Okay. This one right here, I think those were, that looks like a TV to me, doesn't it? You? TV waves, television waves. I'm not putting them there correctly. There we go. This one, I believe that's a microwave, don't you? Microwave. Yeah. And this is like a temperature. Temperature. I think when I've seen on TV, they use infrared cameras maybe for temperatures. Yay. Then visible light. Okay, now, this is an X-ray. I know that. And then I think the biggest one was the gamma radiation, the most powerful light. And that leaves only ultraviolet light, the kind that can burn our skin. Get in there.
Great job. You have labeled the electromagnetic spectrum correctly. The types of light to the left of the spectrum do not carry as much energy as the light waves on the right of the spectrum. Match the type of light to its place on the electromagnetic spectrum.
All right, we just did that.
You've learned a lot about the nature of light. Let's take a quick look at the main points you covered. Light travels very fast and is a transverse wave. In fact, light is so fast that it can travel 150 millikilometers in about 8 minutes. Light does not need a medium in order to transmit energy. Light travels outward in all directions from its source. Light travels in straight lines until it hits an object that the light cannot pass through. Light of different wavelengths makes up the electromagnetic spectrum. Radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays are all forms of light. We use different forms of light for different tasks. Radio waves are used in communication. Microwaves are used to heat food and for cell phone tower signals. Infrared radiation is a form of heat. We use visible light to light rooms. Ultraviolet radiation can be used to disinfect instruments. Doctors use X-rays to diagnose medical problems. Gamma radiation can be used to treat tumors. Laser light is a specific wavelength of concentrated light. It forms a thin beam. Lasers have many uses and have been used to improve many forms of technology. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right, so we've had 2 lessons on light, pretty much covered the same things in both lessons. So you should be pretty familiar with those 9 vocabulary words that I told you to fill in your book yesterday. So today you're going to have an assignment to match those words with their meaning. But I also, before you go to that assignment, I also wanted to show show you something else really cool you can do with a laser light. Have you ever seen a laser light show? If not, then I want you to go to the next slide, and I think you'll enjoy this little video of a laser light show. Thanks for listening. Make sure you get your vocabulary assignment done for today.